You walk under them every single day, in offices, in movie theaters, in shopping malls, but you probably never even notice them. Well, in this explainer, we're going to pull back the curtain on the hidden, precisely engineering system that's designed to save your life: emergency lighting. Okay, just imagine this for a second. You're deep inside a building, maybe one you don't know that well, and then suddenly, everything goes pitch black. So what happens in those first few seconds? Your brain just scrambles, right? It's looking for information it can't get. You feel that jolt of adrenaline. Confusion starts to set in. Then disorientation. And if you can't see a way out, well, that confusion can spiral into real panic fast. And that exact high-stakes scenario is what an entire field of safety engineering is built to prevent. Because look, when the power fails, it might not just be an inconvenience. It could be the first sign of a much bigger emergency, like a fire. And in that moment, when your instinct is to panic, your ability to see is, well, it's everything. Every single second you spend just trying to get your bearings is a second you've lost. So to fight back against that initial chaos, experts came up with this highly regulated, totally standardized system. It all starts with a pretty simple idea, but as you're about to see, it builds into an incredibly complex safety net made of light. You know, the official European standard EN 1838 defines it so simply. It's just lighting provided for use when the power supplied to the normal electric lighting fails. But that really straightforward definition, it hides this incredible world of complexity and detail. And what's so fascinating is that this isn't just one type of light. Oh no, it's a whole family of systems, and each one has a very specific job to do. You've got escape route lighting to show you the path, open area or anti-panic lighting for big spaces, high-risk task lighting for dangerous areas, and of course, the safety signs that literally point the way. So let's start with the one we're probably all most familiar with, the lights that are designed to light up the path out of a building. The standard is unbelievably precise. It says that the floor, right along the center of an escape route, has to be lit to at least 1 lux. Now, to give you some context, that's roughly the brightness of a full moon on a clear night. So it's not bright, you're not going to be reading a book, but it's just enough to see obstacles and find your way. But here's the thing, the light level is only half the story. The speed is absolutely critical. These lights can't take their time warming up. Within just 5 seconds of a power failure, they have to hit 50% of that brightness. And within a minute, they have to be at 100%. This is all about stopping that initial, dangerous phase of disorientation before it can even start. And these lights aren't just scattered around randomly. No, the system is incredibly smart about it. The standard identifies what it calls points of emphasis. These are the places where lights are mandatory. Think about it. Every exit, every change in level, like a staircase, every time a corridor turns, and, crucially, right next to all the safety equipment. And check this out. This really shows the level of detail we're talking about. While the floor only needs that 1 lux, the face of the firefighting equipment and the first aid boxes has to be lit 5 times brighter, to at least 5 lux. And the reason is so simple but so smart. You need to be able to see them clearly, to read the instructions, and to actually use them in a crisis. Okay, so that covers the path out. But what about those huge open atriums, or maybe places with dangerous machinery? Yeah, this system has very specific rules for those, too. And this is where the system is just brilliant, because it adapts to the level of risk. In a big open area, the main goal is just to stop people from panicking, so the minimum light level is actually lower, at 0.5 lux. But in a high-risk area, say near some moving machinery, the requirement is way higher, at least 15 lux. And get this, the activation time has to be less than half a second. That gives someone just enough time to slam an emergency stop button and prevent a total disaster. The standard genuinely thinks of everything. I mean, it even has specific rules for large bathrooms and public swimming pools because they have their own unique risks. It just goes to show how thoroughly safety experts have thought through every possible scenario. Okay, so the lights are on. You can see the path. But which way do you go? That's where the all-important signs come into play. You might think the size of an exit sign is just kind of arbitrary, right? But it's not. It's actually determined by pure mathematics. A simple formula, L equals Z times H, dictates the maximum distance from which you can clearly read it. Here, L is that viewing distance and H is just the height of the sign itself. So what on earth is that Z factor? Well, it's a constant, and it all depends on how the sign is lit. If a sign is externally illuminated, lit up by a separate spotlight, its Z factor is 100. But if it's internally illuminated, meaning it actually glows from within, its Z factor is 200. The bottom line here is that an internally lit sign is clearly readable from twice as far away as an externally lit one of the exact same size. And that makes a huge difference in a smoky corridor or a giant hall. So when you put all these pieces together, the path lighting, the anti-panic lighting, the high-risk area lighting, and those mathematically placed signs, what you have isn't just a collection of lights. It's really a psychological system. It's one that has been meticulously designed to replace confusion with clarity, to fight our panic with predictability, and to make the safe choice the only choice our brain even wants to make. So, what are the key things to remember? First, emergency lighting is a complex, engineered system, not just some random lights. Second, different areas have drastically different needs based on their risk level. Third, that activation speed is just as important as brightness. Fourth, that even how far you can see a sign is calculated with a precise formula. And finally, the whole goal of this entire system is to make safety feel effortless and instinctive, right at the moment you need it most. It's just this incredible system of rules and technology hiding in plain sight, right above our heads, just waiting for the moment it's needed. So the next time you walk into a building, take a second and look up. The system is always there, waiting in the dark. The only question is, will you notice it now?